welcome to my channel. In this video, I'm gonna show you guys how to build a working electric skateboard, including choosing the part and assembling it. Since you guys are already here, I want to tell you guys a couple good reasons why you should build your own electric skateboard. The first reason is cost. You can build a really high spec or the same spec with the top brand company like Skateboard or Evolve board for a much lower price. I'm talking about half of the price. You can spend around 600 or 700 bucks for like a same spec with boosted board. It really depends, but it's obviously will be much cheaper. Second reason is when you want to upgrade the board into maybe better or high speed customizable, you can do it with your own board. The pre-built board like boosted board, evolve board doesn't allow you to basically upgrade it. Maybe they do, but a very small amount of upgrade. You can do it on your own, but since you built the old skateboard, it's easier like to upgrade the batteries, upgrade to dual motors, change your wheels and stuff like that, and not depends on the company out there. They do make money because of that. So it's really up to you guys, but building is you can easily customize it the way you want it to be. The third reason I think is to learn something. Now, building the electric skateboard, I spent a lot of time looking at informations, and to be honest, I learned a lot of things about how to use the motor, this concept of RC motor. So you can apply it to the future, not just skateboard. Maybe I want to put the motors on whatever I want because basically it's the same concept of the electric skateboard. So I do think learning it is really good for you guys if you guys want to learn something. So the cons of building the electric skateboard, probably you have to troubleshoot a lot. It's require a lot of trial, the fine tuning for your board to be able to work in your desire. That's the difference between the company and you. They basically spend a lot of time fine tuning the product so the customer will feel good using it. And instead of they doing it, you have to do it. I do think the hardest part of this project is choosing the right parts. Not everybody using the same part, using the same batteries, using the same motor. They have a lot of specs out there. I spent at least a month looking for the right part for me. I'm a really heavy guy, so choosing the right part is very crucial. It's not an easy process. It's confusing if you're new to RC. I'm also the same. This is my first time building the electric skateboard. I'm also new to RC. I'm no expert, but at least I know something to talk about. The top priority of this video is to help you guys to choose the part. Assembly is, which I think is really easy and not that hard. Using the tool, the computer tool to configure your motor. Most of the information is very basic and at the beginning level. Since this video is 1 hour long, I will break it down to a menu after this so you guys can keep track with it. When I talk about a part or something, I do have the part numbers come in the video. You can track the part number in the description. I think it's easier for you guys to keep track. I do sorry for my English. It's not my first language. I hope this won't kill your ear. I also gonna speed up the video so my voice will sound very funny. Hope you guys will understand it. If I do make mistakes or something, let me know in the comments so I can hopefully correct it. Any comments, I would take it. I really appreciate. So we're gonna jump to the schematic next.
So here's all the part. So before I go through each of these pieces, I'll go ahead and draw a schematic for you guys, a very simple one. so to help you guys like imagine what's going on in this whole skateboard. Okay. Okay, so to build an electric skateboard, you need three main components. The first one is a brushless DC motor. So that will be our motor. A motor need 3 wires coming in. It will all have the 3 wire already. These 3 wires will be connected to an ESC. You can call this one basically a speed controller. It takes in the power from the power source to basically drive this guy. So we have 3 wires coming out. 3 wires. The ESC will basically energize these 3 wires separately in a very fast speed. So it will turn the phase in here in order to make this motor turn as a very fast speed. I'm not going to go very detailed how this brushless motor inside will work, but that basically, it needs 3 wires connect to the ESC. The ESC will need a power source, and a power source have plus and minus DC power source. This power source is our battery. In this case, we use a LIPO battery or LIPO battery. I don't know how you call it. It can be either 6S or 12S. Personally, I use a 6S battery. I'll go detail into these specifications later in battery sections. So that basically 3 main components. You will also need to have the mechanical kit, and this will include what's it called? What's it called? A motor pulley. It's a motor pulley. Connect straight to the motor shop. This motor pulley, you also need a drive wheel pulley. I'm just gonna draw wheels right here. Sorry, very bad drawings right here. These two will connect to each other by a belt. Okay? And to mount this guy to our skateboard, you need a motor mount. Very important one, motor mount. I'm just gonna draw this guy, like a motor mount. This motor mount connect to a truck. Okay? A skateboard truck. Very bad drawing, guys, so sorry about that. Basically it. Okay. So right now I'm gonna go ahead and put the actual part, the actual hardware part, physical part, on top of this schematic so you can have a better look at it. This will be a 6S LiPo battery. They have 2 wires though. This is the balancers for charging purposes. I'll talk about this later. These are 2 main power sources coming out. Plus and minus, I'm gonna leave it right here. Remember, black is minus and of course red is plus. We will have the ESCs, 3 wires, like right here, 3 wires, put them right here. They're supposed to connect to this battery through an XT90 connector. These are XT90s, okay? You gotta leave it like this. Alright. Next will be a brushless DC motor. So, this is my brushless DC motor. It comes in a package, that very short wire, like this short. But I make it much longer so I can mount it differently on my board. But just so you know that these long cables are made separately. Okay, gotta leave right here. These 3 wires will go to these 3 right here of the ESCs. Very long cable, but I'm gonna make it work like this. Okay. Next is mechanical part. We have a motor pulley, very tiny guys. Will be mounted into the motor shafts. It stays like that. We have the drive wheel pulley. Now this part is a drive wheel pulley. I assembled this part already, and I'm lazy to take it out. It's take me, I would say, half an hour to like assemble just this part. It's hard for me to align all these screws. It's very tight though. So just to keep in mind that you need to have the drive wheel pulley fit into the wheel very tightly. Now, if it's not, it will create a wobbles on your drive belt. And very bad situation, you don't want it to happen. So to make sure that you have a really good connection right here. Okay, put them right there. You need a drive belt to connect these two pulleys together. That's a drive belt. A motor mount to mount this motor into the truck. Okay, so the truck will go right through right here. The motor will stay right here. Okay, I'll leave right here, and that's basically it. Oh, you need. Oh, and additionally, you need an RC remote. The RC remote will connect through this part right here. You see the 3 pins? That's the RC receiver will go into there, like this one. Okay, leave like that. Let's go to an RC receiver. RX mean receivers. The TX is our controller. I'll draw my controller. I like my controller. That's the controller. This is a TX transmit. So this will go wirelessly using radio signal, 2.4 gigahertz. Okay? Sorry about that, I didn't draw this one in the beginning. Now, I will go detail into each of these parts, so it helps you to understand and choose your right part though. So, let's get into the details of these parts based on my knowledge. Okay, so these battery are 6S battery. Now what is 6S? 6S means it have 6 cells in there. 6 cells. Each cells will have 3.7 volt each. Now if you time this with 6, you will have about 22 volt. Okay? These cells can be charged to a highest voltage of 4.2 volt of each. Now time with 6, you will have 25.2 volt. So this number is the max voltage this battery can output, the max of it. That's it. It can go, I heard people tell me that it can go low as about 21 volt, but because it's a LIPO battery, you don't want to go further down beyond this number. Otherwise, your battery won't charge no more. That's the depth of it. So when you're using a battery, you need to monitor that it will not go below this point. Okay, but my safe voltage, my cut down voltage is about 22 volt. When I see my battery go to 22 volt, I tend to stop. I don't want to use it below this point. But people tell me that I should go more down to like have a better range with it, but that's just me. I stop at 22 volt. But the max of it is 25.2 volt. Okay. Now 10,000 milliamp. There's a couple guys on the forums that talk about how you estimate the range by the capacity, but I think they are right when they say 5,000 milliamp, you will have about let's say 5 miles. Yeah, that's what they say. And that's kind of true for me though. I have 10,000 and I can ride about 10 miles. It can go more, like I said, but I don't want to go below the 22 volt. Okay, that's what damaged my battery or some sort. It's just my reference that I don't want to go below this point. But 10 miles is very doable with my skateboard. Okay, 15C is discharge rate. Now the discharge rate is how much amps this battery can output. Okay, so 15C, you use a 15 time with 10,000 milliamp, or basically 10 amps, 10 amp hours. That's basically a 10,000 milliamp equal to 10 amp hours. You'll have roughly about 150 amps max. That's the max this battery can output. Okay, you just need, this number is good enough. Actually, you will need about 60 amp for the whole skateboard to push you initially. It need a lot of amp to push you initially until it reach a higher speed, a stable speed, and then it drop down to maybe 15 to 40 amps. It really depends, but I'm not sure about this number. But 60 amps is a good number you need though. So choose the right discharge rate. The higher the discharge rate, the more expensive the battery. Okay, it's not just this number that make it expensive. It's this number that make it expensive. Why you need a lot of discharge rate? Because maybe people riding a helicopter or aircrafts, things like that. They need like 75C and stuff like that. I don't know. I don't build those things, so I don't really know. But 15C is a good number for my skateboard. Okay, that's 60 amps is a good number to reach though. You can have maybe 15Cs, 5,000. You can still reach this number, so that's good. This depends on you. I go with big battery because I'm a big guy. I need a lot of range on that. Basically it. Okay, you can either go with 6S or you can go with 12S. 12S, which means you will have about, let's say, double this, about 50 volts. Okay, 50 volt. Now you have to check with your motor specification how many volt it can input. My motor can input up to 12S. Now some motor cannot. You have to check with that before you put high voltage into your motor and burn it out. That's a crucial case. You need to know your motor specifications. Okay? Now, I have a 6S battery. I want to make a 12S battery. Basically, you need another battery like this. Another one. Another same one, okay? You will connect them in series. Basically in series to output a 12S battery. But that's for the futures. But for the information you need to know. A lot of people will stay with the 6S. I'm happy with the 6S. 25.2 volt will push me a lot. It can reach 20 miles per hour for me. That's a good number. Now people want to go 28 miles per hour, stuff like that. They will need more voltage into it. And in this case, it will be a 12S battery or a 10S battery. Just basically series them together to get a 12S battery. Okay? I will draw a mini diagrams of the battery, how to connect them in series and parallels, and what's the purpose of this. Okay, so let's say I have a 6S, 10,000 milliamp. Okay? Now, I want to stay with the 6S, but I want to double this into, I don't know, maybe 20K milliamp 6S. Now, to do this with my current battery, let me draw a little bit of battery right here. This guy will have a plus and minus. I will need a same exact battery. Okay, same one. Now, a lot of people don't need this because you know how to parallel or series, but I want to make this battery section very detailed for those guys out there that need it. So we will connect them in parallel to do this. Basically, you will connect plus to plus, minus to minus. Now, plus is red. Minus is black. Yeah, black. Now, these two wires coming out right here, plus and minus, will go straight into your ESC. Now, this setup will have total of 20,000 milliamps and still retaining 6S. Okay? That's parallel. That's mean keeping the same voltage, 25.2 volt, and double the capacity. Now, this doesn't have to be 20K. It can be 15K. And basically, you need a 5,000 here, 10K here to get 15K. It doesn't have to be the same capacity, but need to have the same voltage to parallel and get the total of these numbers. It really depends on you. But I tend to parallel the same battery together to double the amounts that I have currently. Okay, I hope that makes sense. And secondly, you want to series them to double the voltage. Okay, so you have a 6S battery, 10K milliamps, and you want to have a 12S battery and still a 10K milliamp. Okay, so basically this battery right here, plus and minus, also plus and minus. You connect this positive side of the second battery into a negative side of the first battery. Okay, and this wire coming out right here is a plus. This wire coming out is a negative. Okay, and this will go to the ESC. All right, that's it. That's how you series it. In series, you need to have the same battery, of course. Have to be the same capacity, because when you series it, the voltage will double, but the capacity always stay the same. Always stay the same in series case. So you need to have the same battery to do this. you have 12S. That's the plan for the future. I'll plan to do this in the future. I order another 6S battery already. I plan to do it in the next video to have 50 volt out of it. I like to drive my motor faster to see what's up. Okay. An additional in choosing the battery is I chose the graphene chemical LiPo battery. Now the graphene is kind of more expensive compared to regular LiPo battery chemistry. The graphene, based on how I do the research on them, they have a higher life cycle. So every LiPo battery have a life cycle too. Let's say you can charge a regular LiPo for like 150, 200 times. But for the graphene, they state that it have much higher life cycle compared to like regular LiPos. They can reach about 500 charging cycle. I'm not sure that's true or not, but that's how they stated. That's called the graphene battery. I will have the link below for you guys. But you know, I don't know. You can choose whatever battery you want to. It's need to have 6S or 12S LiPo. Depends on you. The graphene will cost a little bit more, but I think it's worth it. Okay. Alright guys, so instead of using your LiPo battery, you can also use your Li-ion battery. The LiPo battery is very thick, and the Li-ion battery is super thin, like really thin. But the downside is the LiPo will have a higher amp discharge and also charge the whole thing very fast. I charge my battery for 30 minutes maximum. Li-ion battery can take way longer. I mean, it's not too long, but it's potentially longer than the LiPo battery. So I will make this section right here is to explain the Li-ion battery packs. I do not want to make a video show you guys how to make it because I haven't made one already. But I kind of understand the principles of making these kind of battery. So the Li-ion battery will come in only one forms, as far as I know, is the 18650 battery. If you guys are vapor, you guys should know this battery already. It's longer than the AA battery and have much higher capacity and amp discharge. So for basically this one is, the models of it is a 25R Samsung. So it have 2500 milliamp, nominal voltage of 3.7 volt, and could recharge maximum to 4.2 volt. Kind of about the same with LiPo battery, maximum of 4.2 volt per cells. This battery, for this particular models only, not every models are the same. This is a high drains Li-ion battery. What it high drains does, so this model can discharge maximums of 30 amps. That's the specs of this models only. Some similar 18650, maybe cheaper, they do not have this high discharge. It's not a high drain, but maybe they can drain about let's say 2 amps. They typically 2 amps or around 2 amps. So you have to check for this model as a battery, like how much it can discharge. So on some of the website, if you buy these battery pack, it will say, so let's say this one, 12S and 3Ps, which is 12 in series and 3 in parallel. And okay, so 12 in series, this is one battery. You're gonna have 12 more of this in series. I'm gonna do 12 more. Total is 12. This is 1, 2, plus and minus. This number 12. You're gonna have 12 of them in series, and basically this is 3.7 volt times 12. So you will have around, let me see, 3.7 volt times 12, which is 44 volt. And it can be charged max into 50.4 volt, maximum charge, which is 4.2 volt here. Okay, so you have 12 in series, you have 50.4 volt, but you because you're in series, you only have 25 milliamp, only 25 milliamp hours. It's really it have a really high voltage. We can only discharge. It only have a very small capacity, so that they have a 3P, which is 3 parallel. They gotta do the same exact thing to 12 Ps. Also same exact thing because I have 3 in parallel. I'm gonna do the same exact thing. And they series them together. They series the whole things together to make the total of 50 volt, about 7,500 milliamp. For the discharge, when you series them together, the discharge rate will stay the same. So let's say the maximum is 30 amp. This whole series lines right here can all discharge 30 amps. But when you basically parallel them together, they will add up. The discharge will add up. So it can discharge about 90 amps total. That's the basics of it. So basically, if you guys gonna go out and buy it, you guys should know this number, 12S and 3 in parallel. If you also want to check what battery they have, because if you buy these batteries from reputable company, it's very expensive. The whole battery pack can cost up to $500 or $450. Comparing to China, they make a very cheap battery pack. If you go to Alibaba.com, it's very cheap. Because it's that cheap, you have to doubt the qualities of it. I mean, you have to check for the models of it, the discharge of each cells, and add them up, and basically in this formula to verify their market discharge rate. There's some of these guys on eBay say the battery can discharge, the whole pack can discharge 20 amp in series, and not even parallel. I checked the single cells of it, it can all discharge about 2 amps though. So they have faulty marketing. It can potentially explode, and you know, a lot of hoverboard that explodes on the street because I think they are over discharged, the LIPO or Leon battery inside. When they charge it, they overcharge the battery as well. Over discharge and overcharge can damage your battery. So if you're gonna build this, guys, you need a BMS. Now you have to look up for what a BMS is. Like basically a protection circuit. If let's say when you series these guys together, I have to erase this one real quick. Now charging in parallel, or very safe, basically you're charging in parallel, nothing in series, you basically go very safe. It will charge each of this with a fixed amps and charge it separately. They're not series together. But since you're gonna put it into a battery pack, which is series them, you need a BMS. Now, I'm gonna draw a little diagram here. Let's say we have a 2 battery setup, which is what, 2S? Maybe, yeah. Okay, so when you series them together, the power is gonna go in, it's gonna fill up this battery quicker than this battery. And when it's filled up, it will reach the 4.2 volt. Now, how do you control when it hit 4.2 volt and it will stop, because you don't want to like overcharge the battery over 4.2 volt. Well, this battery probably less than that, maybe 4 volt. I mean, this one will go first and this one will go later. You need a BMS. Basically, the BMS will measure the first battery. If it hit the 4.2 volt, it will stop. I will not charge that one. It will continue to charge the other one until it hit 4.2 volt. It's like a protection circuit. It's to guarantee that every battery in your series circuits will charge up to 4.2 volt and will not discharge lower than, I don't know, 3.6 or 3. I don't know. It will have that low bottom circuits as well. But basically, it will keep your battery from overcharge. This, you have to take a look at this for a couple videos online as they're showing you how to wire the BMS. I highly recommend you do it. I haven't done one yet, so I'm just gonna stop right here. Just that's it. I'm not gonna talk into something that I don't know for sure. So that's it, guys, for the battery section. Okay, guys. So, well, this will be a motor section explanation. So my motor is a torque board, 6355 190 kVs. I bought this guy from DIY-electricskateboard.com. That's why I have a name torque boards on it. Okay, this guy will have a max power of 2500 watts, max amps of 80s, and max voltage of 12S. But right now I'm using just 6S. That's why I wanted you guys to double check how much voltage your motor can hold on to. Typically, that will be 12S, but just to make sure, before you upgrade to another battery or something, choosing your battery. Okay. So 63 and 55. 63 means the diameters of your motor, and 55 means the length of it or the height of it. So why you want to know this number? There is another motor on their website that says 6373, I guess, 70 something. Basically, it will have a longer length on the motor, and why this will be affecting you. So take a look at this diagram. If you plan to go with a single motor, you fine, you don't have to worry about anything. But if you want to go double motor in the futures, or currently want to build one, you'll want to notice this. You want to measure the truck lengths in between them. These are motor mount. If you're using a smaller size, you will have the perfectly aligned, because it's kind of short and it won't touch in between. If you're using a longer one, you will need a longer motor mount. And this happened. I see a couple guys on Google's that make this longer motor mounts to mount the two long motors together. Otherwise, they'll be touching each other, and this is not good. The thing, this is problematic because you have to buy separate motor mount or make one separately, comparing like this, one short and one long. You will need also a different drive belt length to connect to the pulley right here. I think it's problematic, but you will get more power from this big guy because it's longer. It will have much more power compared to 2500 watts. Maybe, I think this is 3100 watts or something. It's much more stronger, but the downsides of it is it's much bigger. It will affect the look of your skateboard. If you don't mind with it, you can go whatever. But this is a reminder, okay? 190 kV. This is a magic number. There's a lot of people talking about this number. But I'm just going to go very basic and explain general information to you guys about this number. So for electric skateboard purpose only, a good kV is 170 to 300 kVs. Okay. So the higher the kV, I'm sorry, gonna move it up a little bit. The higher the kV, you will achieve a higher max speed. Why is that? Because the RPM, round per minute, is mean how many rounds your motor can rotate per minute is equal to the volt, which is, I don't know, 6 or 12S time with your kV. And let's say you have the same 6S, but you have different kV. The higher the kV will achieve higher RPM. The higher RPM, which means you will get a higher speed, a higher max speed. Yeah. So, but the higher RPM doesn't mean that you have higher torque. Now, torque is a different thing comparing to speed. Because I'm a heavier guy, I'm 220 pounds right now, I need a lot of torque to pull me initially when I start the skateboard. While you're going uphill, you need a lot of torque, because torque is like a force that the motor will put into the wheels. I'm just gonna go very basic on that. So with lower the kV, you'll get lower max speed, but you get a lot more torque comparing to 300 kVs. Okay, the sweet numbers in between will be 230 kVs. So for the motor, I make this cable longer extension so I can mount the motor way further away from the ESC. A lot of guys didn't do this, so they have the ESC next to the motor, which I don't prefer. I just want to like kind of separately to look the board nicer. And to do this, it will be, this wires right here is a 12 gauge wire. It's kind of thick. You can buy them at the electronic store or something, or order them online. This is a 5.5 millimeter bullet connector. You need those. You need to buy those from eBay. I'll have a link for you guys. If you guys live in the SoCal area, you can come to like the shop called Rob RCs. Yeah, they have all these, but if you have them online, you can purchase them as well. That's basically it. But if you guys have more information about motor, let me know in the comments so I can add them in, or any suggestions, please let me know. That will be really helpful for the other guy. Okay guys, so we're gonna come into the next small sections in choosing your right kV for the motor. I found this piece of information from the forums. I'll put the link below for you guys. Basically, he's saying that In our VESC, we have the ERPM thing. What's the ERPMs? Basically, the ERPM is equal to our RPM times with 7. The 7 is the pole pairs. Basically, every motor that you purchase for the electric skateboard will have 7 pole pairs. So you basically get a time with 7. For the ERPM, the VESC will only withstand around 60,000. You can go a little bit higher than that, but recommendation is you stay below 60,000 ERPM. So how do you find the ERPM in like a formula? You basically take the kV time with the battery setup. So there's 25.2, which is 6S battery, and also time with 7. You will have 33,000 basically. So 33,000 is way below 60,000 ERPM limit, so it's good. So let's say if you want to power the same kV with 50 volt, which is 12S battery, you will have roughly 66,000. Now this, I mean, a little bit above 60K is good. There's a couple guys testing it out on the forums already, but suggests stay below 60K, or your VESC DRV will pretty much fries or blow and not function no more. So basically, the guys on the forum have a list of you guys to follow, choosing your right KVs. You can do basically 60,000 divided by 7, and also divided by your battery setup. So let's say 25.2, which is 6S. This will equal to 60,000 divided by 7 divided by 25.2 is about 340 kV. So this is the maximum kV motor you can choose to power with the 6S and stay right at 60,000. But to be honest, the 340 is it have the high RPM but really low torque. So if you want to do much higher voltage, you gotta still use 60,000 divided by 7. Let's say maximum is 50 volt, which is 12S. You should have something around 170 kV. So basically, this number 60,000. The VESC developer says 100,000, but they can only withstand 60,000 at this moment. So we expect to have the hardware upgrade from the developers anytime soon. So today is July 5th, that's 2017. If you're still watching this video and this piece of information doesn't make sense in the future, I don't know. But as of right now, it's 60,000. Maybe you have the upgrade, the hardware upgrade in the futures, and basically it solved the problem. Well, there you have it. I mean, but for right now, just basically stick right below 60,000 is good. I mean, around 60,000. Don't go like 80 or 90s. I will have a link to the threads below for you guys to take a look. You guys are welcome to read all the comments there. But basically, I just gotta sum up for you guys right here. So let's talk about ESCs. On the table right here, we have the VESC. It's different from the regular ESC. So the guy named Benjamin Vetters put an MCU, a 32-bit MCU, a microcontroller, onto a regular ESC to make it VESC. Now, I like to say it a smarter ESC. It helped me controlling a lot of information I need for this motor. A lot. For a regular ESC, you basically can connect to a battery, and then DC motors, and then a controller, and that's it. Basically, you can't config anything on this based on what I know. So for the VESC, it can be able to controlling how much voltage, how much amps, the power coming from the battery you want to. Let's say you want maximum of 60 amp go into the motor, but not 80 amps. So that's how VESC will kick in. You were using the tool to do it. Okay, it's much more efficient compared to the ESC because it gives you a lot of tools, I would say, a lot of options. You can configure your whole system in order to make it work in your way. Okay, so this VESC will handle the max voltage in is 14S, which is a lot. This is a lot of voltage. Max voltage, it could go to 40 amps, or continually amps, which is a continually drawing 60 amp. It's pretty good number. It's really high number actually. It's very reliable. You can control the amp input, the temperature input. What I like to use these VESC with the tool is using the cut-up voltage. Now, what's the cut-up voltage? Let's say you're charging your battery up to the max voltage for 6S though, 25.2 volt. Now you run it maybe 10 miles or something, I don't know. It will lower the voltage into 22 volt. Now I would like to have a cut-off start from 22 volt. So when it hit the 22 volt, the VESC will know to use, I don't know, maybe to draw less power. From this point, you will feel like the skateboard is a much less power until it reaches the cut-off end, which is 20 volt. I set it, this is configurable. But you can set this ones up in the tools, the BLDC tool. All you can do is right here. You can go much lower, but I like this number. Like, it will tell me that our battery already touched 22 volt. You'll feel the skateboard much slower, and that's a good number to stop because I don't want the battery to go below this one. I feel like it will damage my battery. You can go lower though, but my reference, I would stop at 22 volt. You can start cut it up at 22 volt. Okay, so that's kind of explaining what I use this cut up mode. I hope you understand it. It really depends on you, how you want it to be. It really depends on battery chemistry, how low you can go, and stuff like that. And one mode that people like a lot is the FOC, or the, how do you call it, field orientated control mode. It will basically give you less noise for your motor. My motor turn, I can hear the noise though. It sounds like a turbo noise. And if you don't want that noise and very silent noise, you can go with the FOC. My personal experience when I bought this VET though, so I bought it and I thought when I connect the battery, the controller, everything together, the controller and everything, I will be able to use it instantly. But not. It actually didn't turn out. I pressed this, the first RC, I pressed it, and then the DC mode turned it's fast, but it doesn't hold us. It cannot pull me anywhere. It's very slow. Now this because you haven't, because I haven't configured the BLDC tool. It will ship to you as a default, how can I say, a default setting, and you have to configure it before you take it out. Otherwise, it will not carry you at all. I stand on it, I press a whole lot of throttles on my controller, and it's not going anywhere. It's going very low, slow, and very low torque as well. You have to configure it before you go out there. Now, it means that you have a power source of 5 volt from this VESC that you can connect to, I don't know, maybe your controller, maybe another MCU. Now, this is a nice topic to talk about because I plan to make like a Bluetooth phone control for my VESC instead of using the radio controller. Now to do this, I need to use another, like the Arduino or the ARM controller. It's kind of advanced though, but to power it, you need a 5 volt. So it's very handy to have a power source at 5 volt coming out from this VESC, so you can power other peripheral that you want to. So let's see. For buying this one, you need to buy a servo, male-to-male servo pin. I will have this link below. This male-to-male will connect from this pin right here, the 3 pins, to the receiver of your radio control. You need this one connect using that male-to-male servo controller and male-to-male servo cable in order to use the whole controller. Now in the assembly part, I will talk about this. Okay, but I have this link for you down there. Alright, so once again, the BLDC tools, there's a lot of versions. A lot of guys on the forum, I highly appreciate that they share their versions of it. I currently use the Maniac guys. There's a guy named Maniac on the forums that make his custom BLDC tools, and I download it, I use it. It's worked for me. I mean, I like it. I will I'll post a link below for you guys. I want to credit that guy as well for helping me. He helped me on the forum how to configure this, guys. Yeah. So as I mentioned, that I bought the whole mechanical kit from the website DIYelectricskateboard.com. It's $199. I do recommend this kit because it can include every single mechanical part that you need, and you don't have to buy them separately on eBay. I did some research on the pricing. If you buy them separately from different websites, especially eBay or Amazon, you will get about, I remember it's about $30 cheaper, about 30 or 25. But it's really problematic. You have to choose a size. You have to worry about how many screws it is, those kind of stuff. That's why I bought this kit, so I don't have to worry about the mechanical part. It's a little bit pricey. I won't say cheap though, a little bit pricey, but I will do my review or tutorial based on the option they have online for this kit though. Okay, so you will first have to choose the motor mount size, which is this, guys. If you're using a larger diameter motors like I do, the 6355, then you have to choose a 63 millimeter motor's mount size. So these screws right here are specifically designed for 63 millimeter. If you're using a smaller size motor, go with the smaller size motor mount as well. These are different. Okay. So the next one you have to choose is the motor mouse pulley. It will come with two options, 16 teeth or 13 teeth. Okay, you only have to choose 16 or 13 for this guy. This one will come with it. So I did a little bit of research. I asked the sales guys at the website, and he recommended me the 16. Okay, so he said the 16 teeth is for better accelerations. A 13 teeth is better for accelerations. Okay, 13 acceleration. 16 is for top speed. Top speed. Okay, that's it. That's all you have to worry about.
So after you plugged in your mini USB to the VESC, you're going to open the BLDC tools window. You go and hit refresh and choose COM5. COM5, which means serial port number 5 USB port. It really depends on which USB port you use on your computer. Mine is COM5, so maybe yours COM7, COM6, COM3 or something. Go ahead and try them out. Mine is COM5, and then you click connect. You see the firmware version is 2.54. This is correct firmware at this moment. If it say connected and also limited, you need to upgrade your firmware. It's probably because you just bought the VESC from the company and they have the older firmware, so you have to update them. Go ahead and go to the firmware tab, press choose, and then OK. Locate the bin files. This one coming from the Schematic guys in the forum. I will link the forum link for you guys. Also, I upload the bin files to a Dropbox so you can download it. Basically, go ahead and open it, and then you press upload. I already did this, so I'm not gonna do it. When you upload it, it will automatically reboot the VESC, and then it will connect again. Basically, you need to see this green firmware versions right here, which means that you already have the latest versions of your firmware. You need to see those. If it's still limited, you have to do it again. Alright guys, so we're gonna go to motor configurations. We're gonna press read configuration. When it's read, every number is gonna pop up right here. Now I'm just gonna, like I said, I will go very basic and help you get your motor working. I'll not go to extremely detail how to use all the modes of this BLDC tool, but for this purpose of this video, get your motor working first. So current limit, this is the limit that from your battery to your VESC. You can limit the current to your VESC is 60 amp. Now, if you want to know like accurate how many amps you want to limit, you have to attach the what's it called, the amp meters or voltmeters to your between the battery and your VESC. So when you write it, you will know exactly how many amps you did charging. So you can limit this amp here. Maybe you need more than 60 or 80, and you can limit them here as well. Battery max. These I leave at default. I don't change anything here. I think it's good. The one that I changed is the voltage limit. Now, minimum input voltage, you want to put it 8 volt. Maximum is 57 volt, which is 12S battery. If you're using more than 12S, you need to change it. Because I'm using a 6S battery, maximum is 25.2 volt. I want to start cut up the battery at 22 volt. So this is a cut up stars, which is the VESC will start reduce your power when it hit 22 volt. Now at 22 volt, I will notice that my board is much slower, and then when it dropped to 21 volt, it will done. The VESC will no longer take the powers in, and your board is basically not gonna work no more. But that's a good point because you don't want your battery to go below 21 volt. It would damage your battery. Now, like I said, you can go lower than this, but do a little bit research on your battery chemistry. How low can you go per cells, and this depends on manufacturer as well. But for good practice, 22 or 21 is good. You want to leave this one, duty cycle, don't want to change it. Next you go to BLDC. You will start detection, and basically when you press this button, your motor will spin. So you're gonna press start detection. The motor will spin for 2 seconds, and then the new values will comes up. When it comes up, hit apply, and a new value will pop up right here. So after that, you want to write configuration. Now every time you do something on this tool, you need to write it using this button. Otherwise, the VESC will stay with the previous value because you didn't write anything to it. So you make sure that you write this one every time. So we're gonna go to app configuration. You can control mode. I use a watch no reserve with brick. You can also use current or duty cycle. In general, you want to click PPM because PPM is radio control. ADC is analog to digital. You don't have to use it right now. UART is basically serial communication, basically USB stuff like that. Nunchuck is the Wii Nunchuck, really cool. You can buy those from DIY Electric Skateboard. They do sell the kit for it. I don't have it right now, so that's why I'm gonna stay with the radio control PPM. You gotta press on the PPM tab. You can either disable or using the mode that I'm using right now. Now, if you look closely, the PWM is staying at around 50%. If you go full throttle, it should reach 100%. If you break it real hard, it will go down to 0%. That's theoretically. The next mode is we want to go back to the motor. You want to go to advanced. I like to config this one. Now, this number you can either put 0.01 to have a really good smooth startup throttle. When you press it, it will not go, it's kind of slowly start up. It's not very torquey. If you want super torquey, you can go for 2 or 0.15, I mean 15. or 3 if you want to, but I like to stay with 15. If you beginner, the default value of this number is about 1.01 already. So try that out first. See if you don't like it. You can raise it up a little bit so you can have a torquey acceleration. That's an FOC, but I don't know how to do this at the moment. I will not go into this one. Yeah, that's basically it. Guys. You want to write it, you want to reboot it, and then you disconnect it. That's it. When you disconnect, everything's gone. And you're ready to go. Charge your battery up. So this is the assembly section of this video. Every one of you guys will have to go through this process. I will go slow as I can, but non-important things I will try to skip forward. If the video not making sense or any comments, please let me know in the comment sections below. I will try to help you guys as fast as possible. Make sure the motor mount is rock solid. You don't want it to wiggle or wobble or anything like that. So next we're gonna put the 63mm motors on it. But remember, when you put it on, don't go too tight though, because you gotta adjust the belt later on. And when you do it too tight, you won't be able to adjust it. So it's just enough to hang the motors onto the motor mount, and you'll be able to move it around for a later adjustment. To mount the motor onto the motor mount, I use the M5 or 5mm diameter screw. You can find those in the Home Depots. These are very effective. Those 5-angle screws that they ship to you in package is not good, and it's always turned loose when you run it at high speed, and that happened to me. I changed those to the M5 Phillips screw. It solved the problem. No longer loose stuff. Just me, but I'll put the link below for you guys. So here we are. We'll be able to move the motor back and forth on the motor mount. It helped a lot to adjust the belt later on. Next we're gonna do the pulley system. This is a drive wheel pulley. This is the motor pulley. Now we put it onto the motor. We will have to use the 2 screws that come with this pulley to tighten them onto the motor. Now if you buy the motor from the website I list below, the motor will come with a 3x3 keyway slot on the motor shop. This is very helpful because when you screw the motor pulley onto the motor shop, it will prevent the pulley to slip away from the motor, and it happened a lot of time. This is really helpful features that they put onto the motor shop. chose to put the washer on the trucks before I put the drywall pulleys on, because there's a lot of time when I'm testing this bore, the drywall pulley are touching the motor mount and basically create a clicking noise every rotations. You got to put the belt inside the pulley first, otherwise you don't have a way to put the belt later on. Have everything connected, it's time to tighten the screw of the motor onto the motor mount very tightly using the Phillips screwdriver. So here you have it, everything connected. It's time for adjustment. Now use your hand to like touching the drive belt. You don't want the drive belt to have a lot of tensions on it. You kind of want it a little bit flex, or kind of not too loose, but just a little bit flex when you squeeze it. You don't want to put like super tension, super hard drive belt, because when you run the board, you will hear like a drive belt noise, like a really weird noise. So just like a little flex to it, same principle to your bike. Just don't go too tight on the belt. Also, more tension will damage your drive belt for a long run. So we gotta put the control system. I use this box to carry out ESCs and battery. It's made out of plastic, very hard, durable plastic. I bought this box from a shop called JK Electronics in Westminster, California. I will link the products below for you guys to purchase this. Very good plastic, and it cost me about $8. As I mentioned, you have to configure the motor through the BLDC tools. So you have to take the VESC and the batteries out with the motor as well. Bring it connect to the computer and configure the motor. I will have the very basic BLDC tool for you guys in this video. So you have to do it, otherwise your motor is very weak and not be able to operate as you want it. Now we're gonna close the box by the 4th screw. You won't have to open the box no more. So please prepare everything's inside before you close it. Test it out. Make sure it works before you close. There's a couple guys asked me, how can I charge the battery without taking the batteries out? So if you see closely, there's a little connection, a yellow connection I make besides the box. That connection allow me to have a key system and also charge the battery from the outside. Now I made it. I found it useful for me. I will show you guys how I made it. But if you guys have like a better suggestions, like for a nicer look, let me know. I just don't want to spend a lot of money like for the on-off system and charging. I just make that little connections there. So I will include a schematic right now. Okay. Good practice. Good to mention. For these cables, you need to straighten them out. Do not. Oh, just remind me. I have learned the hard lessons on this. I fall because it's stalled though. So these are called the tandems wheel. I bought the whole thing for like $40, include the wheels, the pupper wheels, and the metal part, the metal sections. It's kind of cheap. It helped me to gain more stepabilities when I ride at high speed. So that's a lot of time when I'm riding at like 18 miles per hour or 20 miles down hills, and the whole board started to shake a little bit. Now I'm not a good skateboarder. I never skate before this, so I eat crap a lot of time. So I add these wheels on. I feel it more stable for me, but the downside is it accelerates kind of slow comparing to the two wheels because now you have four wheel. Of course, it's like more frictions to it. The more frictions, um, the slower you will accelerate, but you will still reach the the higher max speed, which is 20 miles per hour, but accelerate kind of slow than the previous wheels I have.